Hello and welcome back. And we're going to do a bunch of examples to figure out how we're going to add vector both using sine and cosine law and using component addition and finding the resultant force, the magnitude of it, and the direction of it. So take a look at this problem. We have two forces coplanar and on the same plane. One is about 100 pound and it's at 30-degree angle going this direction, and the second force is 140 pound. It's coming in at this is a 45 degree, and we'd like to know what is the resultant force of this two force and what is the direction of it. So what we're trying to find the resulting force here. I'm just going to do it graphically, and then we're going to do calculate it using the both method. So if I pick this one up and put the tail of this one on the head of that one, just project it back this way, it's going to be something like, I think like that. And then if I take this one and put it over here and project it at that angle, it comes something like that. So we're going to say, all right, our resulting force, therefore, it's going to be someplace around something like this. Okay, so our resultant force is right here. What is the magnitude and what is this angle between here and there? Again, there's two. We're going to do this two different ways. First way, we're going to use the sine and cosine law. Remember, we talked about sine and cosine law. The way we can calculate this using a law of cosine. When the law of cosine says to us r squared is equal f1 squared plus f2 squared minus 2 times f1 times f2 times the cosine of the angle between them. So if you know, we made this resultant force here, and that's going to create a triangle from OAC. So if I just redo this triangle, let me see if I can do it here. We got this right going here, and then we got it's coming here, so it's like this angle coming down here, and then we have this right here. So this was 140, if you remember, and this is basically this leg over there, which is a 140. No, that's taking it back. So this leg was a 100. This being O, A, C, and this leg was over there, so that's a 140. And we don't know this one. So this is a R. And this angle right here, phi, we need to figure this phi out. So if I come and project this right here, this is the angle phi right there. I'm looking for this angle phi. Now, if you look at this, if I project this angle right here, straight line is 180 degrees. So I'm going to say phi is equal 180 degree. So 180 degree minus this angle. What is this angle right here? Well, this angle is the same as this angle between these two right here, between the blue line and the white line, which is 30 plus 45. So 180 minus 30 plus 45. And that's the angle between these two. And that should give me 105 degree. Now we can go ahead and use the equation there, and so I'm going to go ahead and say, okay, r squared is equal, f1 was 100, so 100 squared plus 140 squared minus 2 times 100 times 140 times cosine of 105 equal. All right, so now I found out r is equal 192 pound. You can go ahead and plug this in your calculator and see if you can get 191.8 something. So now we know, okay, our r came out to 192 pound. But I like to know what is this angle between, this is r, what's this angle between here and the x-axis, so I can tell you, okay, where this resulting force, the direction is. And we're going to use another equation. Now, to find out the direction here, we're going to use the sine law. We use cosine law, we're going to use law of sines. So that means r divided by sine, r right here, divided by sine of phi is equal AC, which is basically right here, we said it was 140, divided by the opposite angle right here. And this angle, let's call this theta. And theta is basically the angle between this right here and this resultant force. So it'll be this angle right here, right there. But we don't know what it is. So we're going to go ahead and continue. We say r came out to 192 and divide that by sine of phi. Sine of phi came out to 105. Sine of 105, which is equal, AC came out to be 140, and divide that by sine of theta, and therefore we can go ahead and calculate sine theta. We do a cross multiplication, sine theta times 192, sine theta times 192, that should be equal of sine 105 times 140. So therefore we can go ahead and get rid of this, and we want to now find what theta is. We can inverse it. Then we can say, okay, theta is equal sine inverse, and we had sine 105 times 140 and divide that by 192. And therefore theta comes out to 44.8. So this is the angle from here to the resulting force. But I'd like to know, what is this angle right here, direction? Okay, so that is basically this minus 30. So if I say, okay, that direction, theta x, we call it, is equal 44.8 minus the 30 degree, and that comes out to like 14.8 degree. So it's 14.8 degree from the x. If you come down from an x about 14.8 degree, that's what it's going to be. The method, some people not comfortable with it, but that was there was a sine and cosine law. Let's do the same problem using component, which is a lot easier, and depend on the point of view. Let me erase the board. So the second way, we're just going to use this and break them down to their x component and a y component, and all the x component together, and add all the y component together, and then basically square root them out and find the resulting force, and we can, using a tangent, calculate the direction. What I mean by that, so if this is a 100 pound, this can be broken down. We know this is a 30 degree. Let me just put down this here, 30, and this one was 45. So this has an x component. The x component of it is going to be, I don't know if you can see it like that, and a y component of it's going to be like that. So this will be f of 1 of x, and this will be f of 1 of y. So I'm going to break this one with the both component. So I'm going to have, that's a y component, and say the x component coming this way. If I take that force, let me, right here, that's a 140 pound. I can break that to a different component. I say, okay, this is the x component of it, right here, f of 2 of x, and this being f of 2. And this is the y component of it, f of 2 of y. And we know this angle is 45 degree. All right, let's get to work. F of 1 x is right here. It's equal. The x component of this force is a cosine, so you multiply by the angle between them. It's going to be f of 1 cosine the angle, say call it alpha for now, which is equal, f of 1 was 100 pound, 100 times cosine the angle was 30 degree, and that comes out 86.6. So now I'm going to go ahead and do f of x, f of 2, x component of this one. F of 2 of x, and we're going to say, okay, this way is positive for x, is equal, it's a component of this, which is f of 2, 140, times cosine 45, and that comes out 99. So now f of x, combine both of them, come out to 99 plus 86, that comes out to 185.6 pound. So we're going to go ahead and do the same thing for the y. So f of 1 of y, which is equal to this one right here, it is 100 times sine of 30, which is, that comes out to 50 pound, and it's going up is positive, so that's plus 50. The next one is f of 2 of y, again going up is positive. Because this is coming down, so it's a negative, and magnitude is 140, okay, times sine 45. Sine 45, and that's equal. So that become minus 99. And if we add both of them up, f of y comes out to minus 49. The minus means its direction is down, that's all. So we know how we're going to square it. So we're going to say, okay, F or R, in this case, the resulting force for us, that is equal square root of 185.6 squared plus minus 49 squared, and that will give us 192, and that's what we got from the other one too. To find the direction of the resultant force, we know our magnitude is 192, so where is going to go? And we're going to say, okay, this it's a triangle, because we're going to find the our x. So if I go ahead, if I make a Cartesian coordinate, our f of x came out 185, mean it was 185 this way. So that's 185, and it's in a positive direction. And a y come out to become, let me do this in different color so you see it better. And y come out to be minus 49, so that's 49, and therefore the resultant force is going to be someplace right here, r. And if now we have this triangle right here, we know that's a 49, and that's 185, then we're going to say, okay, this angle, theta, is equal tangent inverse of opposite divided by adjacent, which is 49, divided by 185.6, and that's equal 14.7, and that's what we got from last time. So there's this method and that method, depending which one you feel more comfortable, you can understand it easier, but they both come up with the same result. Let me erase the board. We do another problem using this method component, but with multiple vectors. We're going to go ahead, and we got 4 different forces in 4 different directions, and we want to know what the resulting force is. Very easy. We're going to use the component forces to add this up. Basically, we're going to take each one of these, find out what is this x component and y component, and add it all together. So add the x of this one to x of this one to x of this one to x of that one. Then we have a one force for x. We call it Rx, and do the same thing for y. So I'm going to go ahead and come in and say, all right, we're going to go ahead and use the resulting force. We're going to say the Rx is equal. I'm going to start from here and work around. I got an 8 kip. The x component of 8 kip is going to be, of course, I'm going to say going right is positive. So it's going to be 8 times cosine 25. The next one is going to be, again, going to the right is positive, plus 12 times cosine 30. The next one is going to be, going to the left is negative, so it's going to be minus, and that's a 10 times cosine 60. And this one, again, to go into the left, again, is negative, so it's going to be 5 times minus 5 times cosine 50. And therefore, r of x comes out to 943. It's a positive number. That means direction is going to the right. Now we're going to do the same exact thing for the y, r of y. And that's equal, let me change color. Start from here again. It's going up is positive. And we're going to say 8 times sine 25. Going down is negative, minus 12 times sine 30. Going down is positive, negative again, minus 10 times sine 60. Going up is positive, plus 5 times sine 50, and therefore ry gonna come out to minus 745. 745, that's a negative number, so all it means is going down, the direction of it. If I want to go ahead and say, okay, my r of x is going this way at 943, and my y is coming down at 745. Now you have this, and your resultant force is going to be basically right there. This is your r. And that r is equal square root of 943 square plus minus 745 square. Of course, if you have a negative number, you square it, it's going to become positive. And that comes up 12.02 kip. So this is equal to 1202. But what is this angle? What is this angle? I want to know. I'm going to say theta is equal tangent inverse of 745, opposite divided by Jason, which is 943, and that is equal 38.3 degree. Now let's just do the same problem using Excel. All right, we're going to use Excel, do the same problem and see how we're going to do that. What I have done, I made a heading of force, angle, then f of x and f of y of each component, and I put down the force, which was 8, 12, 10, and 5, just like we have in a diagram right there, and then put the angle between them. So first I'm going to go ahead and do the f of x. I'm going to type in equal, and then put in the number, the force, which is 8, multiply by, then type in cosine, and parentheses open. We got to convert the degree to a radian. Excel does that automatically, so type in RADIANS, just like they have it in front of you, and then open up the parentheses and put the angle in, which is 25 degree. When you close it, you got to close the parentheses twice, so close the function out and click check. Okay, so now we're going to do that Fy. Remember, this is f of x and f of y in the first coordinate, they're both positive. So I'm going to go ahead and say equal, again, 8, multiplied by sine this time, and then we're going to go ahead, parentheses, radians, and then parentheses open again. Then I put the angle in and close it twice and hit check mark. There it is. So now I will come back and clean the direction later, but I just want to go ahead and use the formula and copy and paste for all the way. Grab this and grab the bottom corner right here, go all the way down and do the same thing with the Fy. grab the bottom one and go all the way down, and now we're going to come up. We know the second quadrant, which is 12 kips, is the x is positive, but the f of y should be negative. So I'm going to go ahead and put a minus in front of a C6 and then hit the check mark and made it negative. And then when I come in back to the second one, the 10 kips is negative both ways, so I'm going to put a negative in front of it. Check mark and put a negative in here. Also hit the check. There we go. And I think I made a mistake here. That one should be plus. The 10 kip should be negative. And put a negative right in front of it. And check. So we know this one's negative, this one's negative. The x of the 5 kips is negative. And then the y part is positive. So double check your sign. Once it's all done, just go ahead and hold the top and drag it all the way down and come up to the right here, click auto sum, and that's where we had 942. Do the same thing on this side, get an auto sum of 7. That's where we had. I'm going to clean this up a little bit, grab both of them, right click and go to format cell, hit the number, and just go to the 2 decimal points is good. Okay, and can also center them. There we go. Now the resultant force, we had the equation for it if you remember. Right here, I'm just gonna merge this cell so it's 1 for all of them, and that came out to be equal. Type in square root S Q R T. It should show up right there, and parentheses, and then I'm going to go ahead and what's square root of this squared. So click on that cell and go to number 6, shift hold, and that will give you the power. And then I'm going to power 2. Then we had a plus the next one right here, and it's going to be again by power of 2, like that. Click on that. Then you're going to have should be parentheses closed here. There we go. And click in check mark, see if it works out. There it is, 12.01, and our answer was 1201. Am I right? 1202, yeah. So let's go ahead and format the cell here. Go to number, and 2 is good. 1202. Now let's get the angle. Also, let's merge this cell here. The angle came out to type in equal to get the formula, and then we're going to say degree. As you see, it's right in front of your screen. Then parentheses, we're going to go to inverse of tangent, so we're going to be ATAN. That's for inverse of tangent. And then we're going to have parentheses, and we're going to say what was the opposite divided by adjacent. So it's going to be this divided by the next cell was 943, and close that and hit check mark. It says we found a formula to be tied into it. Correct. I made a mistake someplace. Next click, do you want a correction? Yes. Minus 38. And that's what we had before.
That's how you do it.
Okay, in this problem, we want to find out what is the resulting force of these combined is, and also where is it located. So what I'm going to do first, take this whole thing here, replace this with one resultant force. So it's going to be the resultant force is going to be right here, okay? And that resultant for this one is going to be basically 2 times 14 is 28. So that's a 28 kilonewton, and the distance is probably 7 meters from it right here. So all I done in here, I replaced this with this one resultant force, 7 meters, and then the rest of them is fine. We talked about taking a moment. Remember we said how you take a moment. If you have a rock right here, and you have a long shovel right underneath it, and you want to pick this rock up. So if I say I'm 160 pounds, if I put 160 pound pressure on this, and this the perpendicular distance this way, say this is about 5 feet. And how much force is going to come up this way to pull this rock up? I can't pick this rock up, it's too heavy. So I put the shovel underneath it, and I put 160 pound pressure on it. So I'm going to say, okay, the moment is F times D, has to be perpendicular distance, which is equal 160 times 5, and that is a 800 foot-pound. So that's what moment is. So we're going to use this moment in here to figure that out. I'm going to come back in here now. Let's call this point A and call this point B. And let's come back, take a moment on a point A. Before we take a moment, I want to know what is the resulting force of all these is. So the resulting force is, I got 28 going down, and I got 8 going down, plus 8. So we're going to just, don't worry about the plus or minus sign, it's just down direction, and plus 3. And I got right, 8, 3, and 28. So that is basically minus 39 kilonewton. That means basically the direction is downward. And we don't know, it's probably say someplace around here. And this is our R, which is equal 39. But I want to know what that distance is right here. Let's call this distance X. Okay? So this is the equivalent force of all those combined. So basically we're going to say either we're going to have this or that. What we're going to do is we're going to take a moment about point A. And when we take a moment about point A, it's about the load that's out there, not including this resulting force. The forces that's already there, which is this, this, this. But for this, we replaced it with that one. So I'm going to take a moment about point A, summation moment about point A is equal. And we're going to say if we rotate counterclockwise, that's positive. I'm going to start from the left and work that way. First force I have is this one right here, which is 28. And 28 rotate clockwise. So it's going to be minus 28 times, that's going to become 23 meter. The next force I have is going to come out here is 8. So it's minus 8, that is time 12. And the next one is this force here, which is about 5 feet away, be minus 3 times 5. That comes out to, so that is minus 755 kilonewton meter, time meter. Now, we said all that forces, we can replace them with this blue one, which is R is equal 39. So therefore, if I take a moment of the resulting force about that point should equal that. So I'm going to say, okay, we know that summation R moment is about 7 minus 755. That should become equal R, which is going to again be negative, minus R time this distance, which we don't know is a X. And therefore, we know X comes out to, and our R is 39, so become minus 755 divided by minus 39, and that distance comes out 19.4 meter. Hope this was helpful. If you liked it, give it a thumbs up.